Welcome to this video about sketches in Autodesk Inventor. This video is going to be doing mostly 2D stuff. I'm going to be talking about this draw section and this constraint section. I'm not going to go into making things 3D or extruding or anything. This is going to be pretty much just about drawing. The same way that drafting is about being precise and exact, when you do things on computers, things still have to be precise and exact. That's what we're going to be covering today. If this video is not full screen, I would recommend viewing this in full screen. Inventor has some small icons that I'm not sure you can see if you don't full screen this video. These drawing tools are pretty simple. If you choose line, it's going to be how I'm drawing a lot of my things. There's a very, very poorly drawn L right there. But no matter what tool you're on, if you look in the very bottom left corner of the screen where it says select first corner, that will say tell you exactly how to use whatever tool you're on. So a rectangle will say select first corner and then the opposite corner. A circle will say the center of the circle and a point on the circle, like there. No matter what tool you're on, it'll kind of guide you through. Mostly we're going to be talking about constraint. Dimension is the biggest button for a good reason. It's the most important. If you hover your mouse on these, they can explain what they do. There's a little movie or graphic of what they do. I'm going to start with parallel. If you had a math class that talked about parallel, you should know what this means. If I make these two lines parallel right here, I just have to click on them. They are now parallel. If I choose one and I can bring it closer a little bit. Parallel means that these lines are never going to cross. No matter how long or short they are, they will always be the same distance away from each other. Like railroad tracks. One end of the railroad tracks is exactly 3 feet away from each other. If you go 2 miles, they're still 3 feet from each other. If you go 2 more miles, they're still 3 feet from each other. They never get closer, they never get further away. And these lines, you can do the same thing. They can be angled, they can be far away or close together, but they will never ever cross. They'll be the same distance forever. So I also want this line to be parallel to this line at the end of the L. So just click on those two lines. Now I need to make these 3 lines, the bottom, all the basically horizontal parts of the L. So I'm going to choose the top and that line, and then that line and the bottom. Okay, all those lines are parallel now. It messed up a little bit, so let me fix that. Now, we have an L shape, but it's not really right. If I get perpendicular, perpendicular makes it so that 2 lines will intersect perfectly, or the angle between them is going to be 90 degrees, or normal. Pretty useful. There's also horizontal, so if I grab horizontal and make any of these horizontal, or any of these vertical, then it will snap to a kind of nice orientation. Now we have an L shape here, but it doesn't look very nice. I can just grab these and move things around until it looks about right, but I don't know, that looks kind of weird. And again, drafting is about being exact and precise. So to make this precise, I need to dimension it. There's a couple different ways you can dimension. One way is to measure from one line to another line. So if I click on this line, and move the mouse, click on the next line, and bring the mouse back in the middle, click, that will measure how far it is from one line to another. Now this will only work for parallel lines. If it says inches at the end, that means those lines are parallel. If it says degs at the end, that means those lines are not parallel. What you're measuring is the angle between those 2 lines, which is not the same thing as distance. This is 0.8 right now. It's close enough to 0.5, so I'm just going to make these ½ an inch. And also this is going to be ½ an inch big. So we have a uniform thickness now. This thickness of the L is the same as this thickness of the L. But I need this a little bit taller. Again, I can stretch these out a little bit, but I need this to be exact. So I'm going to say I want that to be, 3.5 inches. And I want this to be 2 inches. And we now have a pretty nice L. Let's see if I can make that a bit shorter. Okay, that looks like it's okay. So this L now has uniform thickness. All the lines are perfectly parallel and perfectly perpendicular where they need to be. This would be a correct letter. So the assignment here is going to be to make 3 letters. There's some simple letters like an H or an I or an L or an F or an E that use only vertical and horizontal parts, like this L. That's one of your letters. One of your letters is going to have a diagonal in it, like an A or a V or an X or a Y or a K. And then one of your letters is going to have curves in it, like a P or a B or an R. So you'll have one of each letter, and they get a little bit harder each time, but none of them are fantastically hard. So if we do an angle one next, I'm going to do an A. Now notice, if I hover my mouse carefully at the bottom, there's a dashed line that comes up. Inventor tries to do the best it can to help you as you draw. This dashed line means I'm going to be drawing this at the same height, or in collinear, I guess in this case, as the bottom of this L. So if I click there, it'll start drawing this rectangle in the right place. And I want this actually to go back to the top of the block. So I'll just click there. Now I'm going to make the A letter inside of here. So I'm going to get the line and draw from the corner to not the middle of the top, but kind of in the middle-ish area. And from that corner up to the middle. And leave that kind of blank area. I'm going to draw another one. If I move my mouse very carefully, you'll see that something pops up right there. This symbol near my mouse right there means parallel. If you're very careful about how you draw, Inventor will automatically put some of these constraints in for you as you draw. So instead of drawing it incorrectly and having to add in parallel later on, you can do it right here. So I'm going to make this parallel. Actually, just going to extra long. And another line. It doesn't really matter where. I'm going to draw extra long, move my mouse carefully until I get that parallel to pop up, and just like that. Okay, so this is going to be the basis of my A. I'm going to save the horizontal crossbar for the A a little bit later. For now, let's make sure that both sides of the A are correct. So I'm going to dimension and measure from the bottom up to that line. Now this is going to be a circular dimension, which means the angle between those two lines. Right now it's about 75. Let's just make that 70. It's a nice even number. The same thing on the other side. From this line to that part of the A, bring it back in the middle. And we want that to be the same thing, so 70. Okay, so now both sides match. And we know these two lines are parallel and those two lines are parallel, so we don't have to do that. So now let's worry about this uniform thickness. So I'm going to measure how far it is between these lines. And if they are parallel, it should say in or inches at the end. Let's make that 0.5. And this is going to be 0.5. Okay, so now it's the same all over. It looks like our lines separated a little bit. It helped us when we drew it, but as we added in these dimensions, it moved them around a little bit. So let's fix that. This collinear is going to do that. I want the bottom of the A to be collinear with the L. So those line up a little bit better. The top with the top, and those line up a little bit better too. Okay. From here, I'm going to start trimming. That's just going to get rid of all the parts I do not need. Okay, so there's the A bit that I need to keep. To end, let's just do the rectangular crossbar. It's about there. Again, the thickness must be the same. It's going to be 0.5. Now to position this, it doesn't really matter where I put it. I'm going to keep it closer to the bottom and trim some of the stuff out that we don't need. Okay, so there's letter A. For a lot of these diagonal letters, I would recommend building a box first and then building the letter inside of the box. If you noticed, some of these, when I deleted this bit, it got rid of the dimensions. They are still correct, but if you drag these around, it can change those. As long as you can see the dimension, it's going to be guaranteed to stay the same. If you do not see the dimension, then it can change in the future. So you can put some of those back in if you like. We're going to do that same thing again. Make a rectangle. And now I'm going to be doing a letter with a curve. I'm going to make a P. To start off, though, I'm going to make the letter F. You can see why I'm doing that in a second. top vertical part of the P. And be very careful about drawing this. You can see that perpendicular icon pops up. Well, this line will automatically be perpendicular to that line now. And now I need a line that goes across. It's perpendicular. And now let's make the horizontal part of the F. So you can see kind of the F area right now. Let's trim some of this that we don't need. Okay, there's our F. Let's dimension all this stuff to make sure it is the right size. Everything needs to be 0.5 inches. Okay, that's good. I'm also going to make this 0.5 inches. You don't really have to, but I'm going to make that just so everything is very, very 0.5. Now this, I don't need to dimension how big this is, because I'm actually going to get rid of this in the future. That doesn't matter at all. And we're going to turn this P into the F by drawing some circles. The circle is going to start pretty much right in the middle. I'm getting a couple lines popping up though. I'm not really sure what we're going to do, so I'm going to just draw it incorrectly. Okay, one circle, and our other circle is going to be a little bit bigger. Okay, we're going to turn this into the P. The last constraint that we haven't used yet is called tangent. And this is probably the coolest and the most useful yet. If you can watch that video, tangent makes a line and a circle touch at one point. So if you can imagine a basketball sitting on the ground, those are going to be tangent. The basketball touches the ground only at one point. And then if you rest a book on that basketball, the book and the basketball will touch only at one point. So for these, I want that circle and this line to touch once. If you zoom in very, very closely, and these lines were not as thick, you can see they only touch once. They don't cross twice, and they do touch once. It's a nice thing to understand. So that circle and this bottom line are also going to be tangent. This is a way to get a nice smooth transition from a line into a circle and then back into a line. And there's a very, very even transition right there. Now this smaller circle is going to be tangent to this bottom inside part of the F. Okay, so you should be able to see where the P is going to be at now. Let's get trim and trim some of the stuff that we don't need. Okay, it got rid of a lot of the dimensions for us, but everything should still be the right size. If we dimension how far it is from one circle to another, it is still 0.5 inches, which is good. And if you zoom in here, you can see a very, very smooth, even transition from a line to a circle. That's what tangent does. It's very useful. And here we have lap, a very uniform line thickness of the L, the A, and the P. Inventor is about precision and exactness. If a line looks about right, it's not good enough. You do actually have to dimension it or constrain it so that it's going to be correct. It's not enough that lines look parallel or they look straight or it looks about half an inch big. It really needs to be half an inch if you want it to be half an inch. So if you need to rewatch parts. One part that confuses students the most is when you do something like this and this window pops up. Let me explain this for the end of the video. Adding this constraint will over-constrain the sketch. Now, this comes up when you are trying to do something and it kind of breaks the rules of what Inventor understands the part to work in so far. What I tried to do just then is try to make these two parallel, which obviously can't happen because right now they're perpendicular. It definitely wouldn't work. If I even have tried to make a horizontal line vertical, it says the same thing. Sometimes, if you're not careful about drawing things at the very, very beginning, it adds in some of these constraints for you. So if I draw that right there, you can see a perpendicular pops up right here for that to be perpendicular. If you don't want it perpendicular in the future, you need to not have it in right now. There is a way to go in and later on and delete some of these constraints that you didn't want there in the first place, but it's easier if you avoid them as you draw. So As you draw, be very conscious of what constraints Inventor is using and automatically adding into the sketch as you draw things. A lot of people are frustrated using these constraints because Inventor is not doing what exactly you want it to do. A lot of that comes from misunderstanding what these constraints do or what they're for. So spend a little bit of time and understand what the difference is between parallel, perpendicular, tangent. There's an equal, there's a dimension. Understand what the difference is between angles and dimension like this. Some people are confused by two lines that look parallel. Like those look parallel, but if I dimension between them, that's 0.5 degrees, not inches. So if I can say 0.5 and it'll look 0.5, but you can see that these are further apart than these are. And even though these look parallel, that's 0.5 degrees apart, not 0.5 inches, which is worlds apart. It's two completely different things. So just be careful. Be aware of what you're doing and what you're building. If you need further help, you know where to find me.